So here we are having the 18th question, and we have to prove that I plus A is equal to I minus A times the matrix given. So let's see how to do this question. So first of all, we have to do the left hand side. So in order to make our writings easier, instead of tan phi by 2, we can put it as the constant t, okay, because it will make us write more. We have to write a lot of tan phi by 2, so instead of that, let's make it simpler and put it as t. So a can be written as 0 minus t, t and 0, right? Now we have to find out a plus I. So I plus a or a plus I would be whatever is I is identity matrix, but it has to be of the same order. This is 2 by 2 matrix, so this also is a 2 by 2 identity matrix. So writing A, now just add them. 1 plus 0 1, 0 minus t minus t, 0 plus t would be t, and 1 plus 0 would be 1. Now finding out the right hand side, doing this part first. I minus a, it is the same thing which we did before, but with a negative symbol in between. So now 1 minus 0 would be 1, 0 minus t would be plus t, and 0 minus t would be minus t, and finally 1 minus 0 would be 1. So already we found out I plus a, this is the left hand side, right? So now we are doing the right hand side. I minus a, we already found it out. Now instead of cos alpha and all, we have to replace other elements by using certain identities in trigonometry. First identity to be used is cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta, and sin 2 theta is equal to 2 tan theta by 1 plus tan square theta. So if you check here, we are having cos alpha, right? Cos alpha, here 2 theta is there, here only 1 theta, that is 1 alpha is here. So instead, same equation, instead of theta we are having alpha by 2, because 2 theta is equal to 1 alpha, right? And instead of theta it should be alpha by 2, right? So same thing, we are replacing by alpha by 2 everywhere. Then we already wrote it as tan phi by 2 is t, right? First we defined tan phi by 2 is equal to t. We wrote it already, right? So instead of tan phi by 2, put it as t, so t squared, and here also t squared, right? Now sine also, if you check, instead of tan theta we can put it as t, and instead of tan square theta we can put it as t squared. So writing the same thing, now replacing this part of the equation with this one, and I minus a we already found out, it is this one, right? 1t minus t 1, and instead of cos phi we can put it as these things, right? 1 minus t squared by 1 plus t squared. Next minus sin phi, right? So it should be minus 2t by 1 plus t squared, then plus sin phi, so 2t by 1 plus t squared, then finally cos phi, 1 minus t squared by 1 plus t squared. Now we have to just do the multiplication process as usual, first row with first column. So 1 multiplied with this would be same, 1 minus t squared by 1 plus t squared. Now t multiplied with 2t would be, t into t would be t squared, right? So 2t squared by 1 plus t squared. Now second column, right? 1 with minus 2t would be minus 2t itself, right? 1 multiplied with anything would be the same number. Then t with this number, right? So it would be t times 1 would be t, and t times t squared would be t cubed. Okay, t cubed by 1 plus t squared, and this you have to add. Now second row, minus t times this thing, right? So minus t into 1 would be minus t, and minus t minus t square, minus minus would be plus, and t times t squared would be t cubed by the denominator, plus 1 times 2t would be 2t by the denominator. Now second row, second column, minus t times minus 2t would be minus minus would be plus, and 2 is there, t times t would be t squared by 1 plus t squared. Now 1 times this thing would be same, and you have to add it, right? So now you have to just simplify. So 1 minus t squared plus 2t squared, it would be 1 plus t squared, right? 1 plus t squared, because 2t squared minus t squared, it would be 1t squared, and writing the same denominator, right? Now t minus 2t would be minus t, and minus t cubed is already there, and we can write the same denominator. Now minus t plus 2t, that is 2 minus 1 is 1, right? So plus t, and t cubed by the denominator. Then 2t square minus t square would be 1t squared, and 1 is also there, plus 1 by t square plus 1. So if you check here, this numerator and denominator are same, so the answer would be 1 here, and here also the answer would be 1. So as we were doing here, we can take the minus out common, right? We can take the minus out, and t also we can take 1t out. This also has 1t, and this also has 1t. So whatever will be left, it would be 1. We took minus t out, right? So it would be 1, and plus we took minus t out from here, so only t square would be left inside. So denominator, write it as 1 plus t squared. Then this one also we can take 1t out, right? Then what will be left inside? 1 plus t squared by the denominator, and this one cancelled each other out, so it would be 1 here. So now if you check, 1 plus t square is there in the denominator and also in the numerator, so you can cancel each other out. So what will be left over? Minus t, here only t is left, and here 1. So this is our right hand side of the equation. So if you compare it with I plus a, right? So if you check, both are the same answer. So we have proved that this is equal to this, right? So this is how you do this question.